Dear students, this is a very short video dealing with Dirac's delta function and its Laplace transform. Before defining Dirac's delta function, we'll first define a function whose limit becomes Dirac's delta function. So let's have the function whose limit is Dirac's delta function. First of all, we define fk of t minus a, which is having two values. One value is 1 by k when t lies between a and a plus k, and on all the other parts of the real line it is 0. So it's having 1 by k, it's having a value 1 by k which is non-zero in the interval a and a plus k, and all other parts of the real line it is 0. So here in between a and a plus k it is having 1 by k. Now all the other parts it is 0. So you can see that the area here is 1, that you can see by using this integral actually. Integral 0 to infinity of that function with respect to t. The function is having the value 1 by k in between a and a plus k, and all the other parts it is 0. So 1 by k can be wrote out. It will be integral 1 integrate means it's t. T between a and a plus k means it is a plus k minus a and a will be cancelled, will be getting k by k is 1. So that integral is 1, means area of the total area under the curve is equal to 1. Now, if using unit step function, you can write that function fk of t minus a as u of t minus a minus u of t minus a plus k by k. This is we have seen in the case of a branched function. Look at this function. It is having the branch 1 by k and 0. So between a and a plus k it is having. So it is u of u of t minus a minus u of t minus a plus k into the value of the function. That is how the fk of t minus a. See, when you express the thing like this, you can easily find out you can easily find its Laplace transform. So Laplace transform of unit term function is e raised to minus as by s. So 1 by k is outside. Laplace transform this one is e raised to minus as by s. S here it is e raised to minus a plus k inverse by s. So 1 by s is common, which is taken outside. So this is the Laplace transform of this defined function fk of t minus a. Now we define what is Dirac's delta function. Dirac's delta function, delta of t minus a is limit of fk of t minus a, where k tends to 0. So for the examination point of view, you have to first of all define fk of t minus a, and you say that Dirac's delta function is limit of that fk of t minus a, where k tends to 0. Now already we have seen this is the Laplace transform of fk of t minus a. When we take the e raised to minus a as outside and k is brought inside, it is e raised to minus as by s into 1 minus e raised to minus ks by k. So Laplace transform of Dirac function is limit of this Laplace transform of fk of t minus a. So limit of this function when k tends to 0 means e raised to minus as by s into limit of this one. Therefore, you can see that limit of this one using this L'Hopital rule will be same as 1. You will be getting it as s. Then it is e raised to minus s by s into s, which is e raised to minus as. Therefore, Laplace transform of Dirac's delta function is e raised to minus as. Now, one important remark: when s is 0. When a is 0, it will be Laplace transform of delta of t, that is e raised to 0, which is equal to 1. So that is very important to remember. Laplace inverse transform of 1 means Laplace transform of L of t is 1, means L inverse of 1 is delta of t. That is how we compute L inverse of 1. Remember, L inverse of 1 by s is t, and L inverse of 1 is equal to delta of t. So L inverse of a constant will be c into that constant into delta of t. This is how we do the problem. So this short video ends here, and in this video we have dealt with a definition of Dirac's delta function and its Laplace transform. Thank you for watching.